Welcome to my channel. Today we are going to learn concept of sink and float. Watch till end to see how heavy metal ships floats over water.
Humans have a built-in intuition about how water works. If an object is heavy, it sinks. If it is light, it floats. This logic holds up when a stone plunges to the bottom of a pond, while a lightweight plastic toy bobs safely on the surface. But that assumption fails the moment you drop a tiny, incredibly light metal paperclip into a glass of water. It drops straight to the bottom. Contrast that with a standard basketball, a significantly larger and heavier object. When you push the basketball underwater, it launches right back to the surface. The light paperclip sinks, and the heavy basketball floats. Raw mass does not decide what sinks or floats. Other physical variables dictate the outcome. The governing principle is buoyancy. Buoyancy is determined by density, the ratio of an object's mass to its volume. Water has a density of exactly 1 gram per milliliter. If an object packs more than 1 gram of mass into that same space, it sinks. If it packs less than 1 gram into that space, water pushes it up, and it floats. To understand why objects float, we must examine their internal composition to see how they interact with this density ratio. We can observe this by dropping two objects with identical external volumes into a tank, regular Coke and Diet Coke. Despite their identical size, the regular Coke sinks while the Diet Coke floats. Since their outer dimensions are the same, their different densities result from internal factors. The culprit is dissolved sugar. Regular Coke contains a high concentration of sugar syrup. This sugar adds mass without increasing the can's volume. It packs the liquid tightly, pushing the total density of the can just over the 1 gram per milliliter threshold. Diet Coke uses artificial sweeteners that are significantly more potent than sugar, allowing for a much lower mass of sweetener to achieve the same taste. Without the weight of the sugar syrup, the can is mostly composed of water and air. This composition keeps the total density safely below the sinking threshold. This brings us back to the basketball. On the court, it appears to be a heavy, solid object. However, its buoyancy is dictated by its internal structure. A basketball consists of a hollow shell rather than a solid mass of heavy rubber. The ball is a thin, dense boundary surrounding a massive volume of trapped air. Air is significantly less dense than water. When the rubber shell's weight is averaged across that air, the total density falls well below 1 gram per milliliter. Geometry and empty space provide the necessary volume to reduce the ball's total density, ensuring it stays on the surface. We can apply these same rules to a colossal multi-ton metal megaship. Steel is nearly 8 times denser than water. If density were the only factor, this massive hull would sink instantly. But like the basketball, the ship's interior framework is mostly empty space. Cavernous rooms and halls filled with air drastically lower its average density. To keep millions of pounds of steel afloat, engineers must also utilize displacement. You see displacement when you dropped an ice cube into a full glass of water and the liquid spills over the rim. The overflowing water represents the exact volume of space the cube pushed out of the way to enter the liquid. To float, an object must displace an amount of water that is equal to its own weight. Engineers design ship hulls to be wide and deep to maximize the volume of water the vessel can push aside. The hull must displace enough heavy water to equal the ship's total weight before the ocean level reaches the top of the vessel. Because the ship holds such a large volume of air, its total average density remains lower than the water it is displacing. Maritime design treats buoyancy as a calculation where mass, volume, and displacement are intentionally balanced. By aligning these variables, engineers turn thousands of tons of steel into stable vessels capable of navigating the open sea.
Thank you for watching. If you want to see more such videos, do like, share, and subscribe to my channel.